Okay guys, in order to get ready for our quiz on this material, we're doing the extra practice that is attached to On Campus for this stuff. It's not an assignment, it's just a chance for you guys to get a little more practice. So I would strongly advise before I run through these problems, you should have tried them on your own. Don't just sit here and watch me do these. You should have already attempted these on your own, and therefore you can use this as kind of like an answer key, but it's guided because you're going to watch me go through them. So if you haven't done them, hit the stop button and go try them and then come back. Or maybe you want to try the first one and then come back and watch me do it. Try the second one and come back and watch, and so forth. So here we go. First one, again, main thing here is that these are equations. We're trying to solve for this first example here. So here we go. First rule of solving is making sure that we are set equal to, well, actually the first rule of factoring or of solving is to make sure that our x's are all just regular x's, which they are, and we are set equal to 0, which we are. So we are good to go ahead and start our first rule, first actual action we're going to take is to factor. So I'm going to take a sine of x out of each of these, and we're going to be left with the sine of x minus 2 equals 0. And then all we have to do is take a look at each factor and set each factor equal to 0. So we have either the sine of x equals 0 or the sine of x minus 2 equals 0. For the sine of x minus 2 equals 0, we add 2 to both sides and we get sine of x equals 2. So we have our two issues here. For the sine of x to equal 0, we can look at our basic coordinate plane, and we look at 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And we can say, all right, where is our sine value? 0. And our sine, of course, goes with y. So we're looking at the y coordinates. So we can see a y coordinate of 0 here and there. And those two angles, of course, are 0 and pi. Now, this came up in one of the problems in the homework where we had something like the sine of x equals 2. And don't try to draw a triangle or anything like that. If this number over here is ever bigger than 1 or less than negative 1, you could just stop because there is no angle that would have a sine value of 2. What it means is that your opposite side would be 2 and your hypotenuse would be 1. So this angle right there has a sine of 2 over 1, the opposite over the hypotenuse. But that can't happen. You can't have a leg of a right triangle that's longer than the hypotenuse. So this just yields no solution. So there we go. Our solution is x equals 0 or pi. Done. Okay, moving on to the next one, number 2. We are set equal to 0. Check. Our x's are all regular x's, no negative x's or pi over 2 minus x's, and we have cosines in our terms. We were strictly in terms of one trig ratio, so we are ready to go to try to factor this thing. So I'm going to set up my parentheses, set it equal to 0. You may benefit from doing something like calling calling the cosine of x something like some other letter like w, and then rewriting this expression as 2w squared plus 3w plus 1 equals 0. And maybe it's easier for you to factor when it's just a variable and not a trig function. And I think we're going to need a 2w and a w. We need to have 1s here and here because these two numbers multiply to get 1. So I think everything's going to be positive. And you should really double check your factoring. On the outside we get 2 w's, and on the inside we get a w, and together there's a 3 w's that we need. So we can use this as our model for our factored version. So we're going to have 2 cosine of x plus 1 and cosine of x plus 1. Set each of these equal to 0. Maybe I'll do this guy in red. So we would have 2 cosine of x plus 1 equals 0, which is like 2 cosine of x equals negative 1, which is like the cosine of x equals negative 1/2. And we'll go figure that out. And then this guy is the cosine of x equals, the cosine of x plus 1 equals 0, which is like saying the cosine of x is equal to negative 1. And now we'll go figure that out. So, we are... Okay, I'm going to choose to look at this blue guy first, and for the cosine to be negative 1, we can steal our picture that we used up for the first example, and cosine, remember, is going to be related to your x-coordinate, and the cosine is only negative 1 right there, and that angle is pi. So we'll say x equals pi is our one solution there. Now, for this red guy, for the cosine to be negative 1/2. First of all, you've heard me say it in class a million times, if the cosine is negative, that's going to restrict us to either the top, the bottom, the left, or the right. And remember, cosine goes with x, and we need our x's to be negative. This negative sign there means our cosine is negative, which means we're to the left side of the circle. So I've got to have a cosine equal to a negative 1/2. So that means I'm going to have something like this, where this is negative 1 and my hypotenuse is 2. The adjacent is negative 1 and my hypotenuse is 2. So it could be either one of those angles. Now, you should recognize that angle that is right in here, that reference angle. Do you know it? Do you know it? Well, if you're saying pi over 3, that's it. So that angle down in there is pi over 3. But the question is, what is this angle that gets us there? And that angle is 2 pi over 3. So one of our solutions is 2 pi over 3. And then we just have to think about, I'm going to use blue here for a second to say what angle would this be that gets us all the way down there. Pi over 3 past pi. Again, that angle in there is pi over 3. So to go to this position would be pi, and then we're going an extra pi over 3. So pi plus pi over 3 is 4 pi over 3. And there's our two solutions that we get from the red guy over here. So we have two solutions, 2 pi over 3 and 4 pi over 3 for this guy, and we got one solution out of the blue guy. And so altogether, we would have this as a solution and then these two guys. So make sure you box them or circle them or something like that. Okay, guys, we want to get started on number 3 here. I think the first thing you notice is it's not set equal to 0. So what I think I would do is immediately subtract 1 from both sides. And so if we subtract 1 and subtract 1, we're going to get negative 2 cosine squared x plus 3 sine of x is equal to 0. Now at this stage, you want to take a look. Now, we've seen this before where we have cosines and sines mixed in our equation. And I just want to emphasize, if you have a regular sine or a regular cosine, one that's not being squared, you're going to have to leave it as is. However, this cosine being squared is the key to doing this problem. We're going to make sure we convert that cosine to sines. And as soon as we do that, we're going to be in shape to maybe get this thing factored. And then we can set each factor equal to 0 like we did up in number 2. So with this example, with cosine squared, I'm hoping you know that what the replacement for that will be. We're going to keep the negative 2 out in front, but that cosine squared is going to become 1 minus sine squared. And once we do that, we can distribute that negative 2, and we should get a nice little quadratic pattern. So distribute the negative 2, we're going to get negative 2 plus 2 sine squared plus 3 sine of x. And now, with this quadratic pattern that we have with the squared term, the regular term that's not squared, and then the constant, let's rearrange those to get them in descending order. So here we go, 2 sine squared plus 3 sine minus 2 equals 0. And now we're going to set up our parentheses so we can get this guy factored. Again, we're going to be looking at the front number and the back number. They multiply to get negative 4, and the middle number is a 3. So we need to find numbers that multiply to get negative 4 and add to get a positive 3. And the two numbers that do that are positive 4 and negative 1. So that means that we're going to need to have positive 4 signs and negative 1 signs to get 3 signs in the middle. So what I'm going to do is, in order to get this 2 that's at the back, we need to have a 1 and a 2. Or maybe it's a 2 here and a 1 here, or maybe it's whatever, the 1, 2. In order to get 4, though, that we need, I'm going to put the 2 back here and put the 2 there like that, and the 1 here, and then realize that that better be plus and this better be minus. And that's going to get us 2 factors that we can set each one equal to 0. And this first one over here, I guess I'll underline that guy in blue. Let's get that blue guy. 2 sine x minus 1 equals 0, which means the sine of x, or I guess I should say 2 sine of x equals 1. So sine of x equals a half. And how many times have we seen that in the last couple of days? When the sine of x equals a half, we should know what angles are going to get us that. At the top of the circle, you're going to have a 1 there and a 2 here. That reference angle will be pi over 6, and it's going to happen again over on this side. The 1 there and a 2 there, and again that reference angle is pi over 6. So the angle that got us there is 5 pi over 6. 1 short of 6 pi over 6, as I always say. So x equals either pi over 6 or 5 pi over 6. And now we go to this other function, or the other factor, I should say, with a that's underlined in red. Take a look at him, and I think you can realize it's a whole lot like this one up here that we saw earlier with the sine of x minus 2 equals 0. With this red guy, we're going to get sine of x plus 2 equals 0, which means the sine of x would have to equal negative 2. And for the same reason we talked about up here in number 1, that just can't happen. So we cross that guy out with a no solution that we get from that. And we can just put a box around this thing as being our only 2 solutions. Okay, so now we're going to move on to these problems, which are verifying identities. And now the key is to remember that you can't move things from one side over to the other. For example, I would not be able to add 2 tan x to both sides. We're going to show that the left side is exactly the same as the right side. Now we can do that by making substitutions, multiplying by something over itself, multiplying by 1, and basically changing everything to sine and cosine. So that's what we're going to do on this first problem to get started. Over here on the right side anyway, we will say that secant squared is 1 over the cosine squared, and negative 2 times the tangent of x, that's going to be negative 2 times the sine of x over the cosine of x. And we'll let that sit there. Now, with this 1 minus tangent squared here, of course that means we're taking 1 minus tangent and multiplying it by itself. So we're going to FOIL that out, and we're going to get 1 minus 2 tangent of x plus tangent squared. And I think I'm going to leave that as it is for the minute, and by that I mean this stuff over here. Leave that as it is for the minute, and then see what I can do with this stuff, turning it into sines and cosines. So I'm going to do 1 minus 2 times sine of x over cosine of x, and then tangent squared is going to be sine squared over cosine squared of x. Now, because I've got some cosine squareds in the denominator here, and I've got a cosine squared in the denominator there and a cosine, I am a little curious about this 1 here. So I think what I'd like to do is maybe make him have a com denom with the cosine squared, and if I need it, I can do it to this term as well and give him a cosine at the bottom and a cosine at the top. But I think I want to focus on this 1 right now and turn that 1 into cosine squared over itself. So cosine squared over cosine squared of x minus the 2 sine of x over cosine, and then plus sine squared over cosine squared. Now it would be a good idea to kind of sit back and take a look and say, what do we have here and what do we have here? And what I really like is this negative 2 sine x over cosine x, and a negative 2 sine x over cosine x. So I'm just going to leave those guys untouched. So then if I look at these two guys, you should recognize we have a common denominator of cosine squared, and so that means we can just add the numerators together, and I think everybody should certainly recognize probably our biggest identity, which is sine squared plus cosine squared equals 1. So these two terms, I guess I'll just put them together like this, highlight it like that, and say those two guys together would make cosine squared plus sine squared all over cosine squared. And again, I'm just going to keep untouched, not going to touch this negative 2 sine x cosine x. And I think you can see, I'm running out of room now here, and I can't shrink this right now, but I think you can see that term right there is going to turn out to be 1, and we're going to be done, because once we turn that into a 1, we'll have 1 over cosine squared minus 2 sine over cosine, and we have 1 over cosine squared minus 2 sine over cosine. So we're going to consider that a victory and move on to the next one. Which again looks like it's got some tangent, secants, and cosecants in it. So we're going to convert everything to sines and cosines. So I'm going to start with this 1 over tangent, and I guess I'm going to go the long way here and say that's 1 over the sine over the cosine, and add that to the tangent, which is sine over cosine. And we're going to say that that's equal to the secant, which is 1 over the cosine, times 1 over the sine, which is the cosecant. Now, you probably recognize that 1 over the tangent is the cotangent, and we could have just done that first and then said cotangent is cosine over sine. But the bottom line is we have to fix this guy. 1 over a fraction is the reciprocal of that fraction. For example, 1 over 2/3 is 1 multiplied by the reciprocal, which of course is just going to be the reciprocal. So in this case back here with this guy, that's going to turn out just to be cosine over sine. So we get cosine of x over sine of x plus sine of x over cosine of x. And as you can see, I don't know whether you notice it or not, but this right side is literally one fraction. Even though it's two fractions being multiplied together, the rules of fractions tell us we can just multiply those two guys together, multiply the tops together, and multiply the bottom together. And that's going to give us 1 over the product of cosine and sine. We talked about this a lot in class, where we say there's one fraction on this side and there's two separate fractions on this side. And right away that should give you a clue that you're going to be getting a common denominator over here. We're going to need to jam these two fractions together so that we can have one fraction. And when we do, I think we're going to be done pretty much. So this fraction on the left, the cosine over sine, that needs a cosine in the denominator. So I'm going to give him a cosine of x right there. So we're going to go cosine of x, and we're going to give him a cosine in the top. And this guy, again, I'm doing this kind of tight for space because I'm running out of space here, but this guy needs a sine in the bottom, so we have to give him a sine in the top. And now you can see the denominator on the left, the common denominator, is the same as the one on the right. We've got a cosine times a sine for both of these terms. Meanwhile, look up here, and you see cosine times cosine, and we've got sine times sine. So our numerators become cosine squared plus sine squared, and our common denominator is cosine sine. And I think you can tell that with just like the last problem that we did, that substitution is going to give us 1 over cosine sine, and we're done. So I'll just squeeze that in down here, 1 over cosine sine equals, I'll put the check mark there to show we're done. Forgot my check mark. Well, I didn't really have a check mark because I still needed to make that last substitution up on that first one. But there we go. So we got 1 to go, and this one looks like it's got sine over 1 plus cosine and 1 plus cosine over sine. Again, two separate fractions here, one fraction here. We might wind up going common denominator. I think we've seen something like this somewhere along the way, but I tell you what, I think I'm going to move to a new page, and so we have a little bit more room to work down here. Actually, you know what I can do is just recopy it up here. Let's just put a wall over here. And I think we could just kind of recreate it over here. So I'm going to put sine over 1 plus cosine plus plus 1 plus cosine over sine, and that is equal to 2 cosecant. So I think the first thing I want to do is take a look at this right side and say 2 cosecant, knowing that that's not a sine or a cosine. Let's convert that guy. So we're going to call him 2 times 1 over sine, and which we'll just call that 2 over sine. Now, the left side, I'm thinking we can either go com denom, or we can try to create a sign as our denominator. Like, for example, this guy has a sign for a denominator, and our right side has a sign for a denominator, so we may not want to mess with him. And maybe this guy, we can try to get him to be a sign for a denominator. So I think I want to go that route because it'll be a little cleaner. And basically that means I'm not going to touch the right term here. I'm just going to leave this as 1 plus cosine over sine. And on the left side, we're just going to try to get this denominator to look like a sine. But you've heard me say a lot, if you got a 1 plus cosine, multiply it by 1 minus cosine. And what's going to happen is you're going to get 1 minus cosine squared, which of course is sine. And so let's see what happens when we do that. I'm going to take my sine of x and put it over 1 plus cosine. And I'm going to multiply that guy by 1 minus cosine over itself. And put some parentheses here to remind us that that's a thing. Talked a little bit about this. When you're multiplying something that's not the conjugate, don't distribute it in. There's no need to put this sign into that and the sign into that and muddy that up. If we need to do that later, we can, but for now we're going to leave that untouched. So I'm just going to take my numerator and leave it as sine of x times 1 minus cosine. Meanwhile, we can leave a second fraction the same as it was. And now take a look at our denominator over here. 1 plus cosine times 1 minus cosine. I'll write that as its product, which is 1 minus cosine squared. And then that's the key to this problem, that is going to turn into sine squared, and we're going to be able to cancel a sine, and we'll have a like com denom. So I'm going to rewrite the numerator, sine of x, 1 minus cosine, over sine squared, plus 1 plus cosine over sine. And now we can realize that we can do some canceling. Okay, sorry about that. My audio cut out for a second there, but so you saw this work get done without any commentary on it. But we were where we last left off. This sign got canceled with that one, which left us one factor sign in the denom with the 1 minus cosine. That guy got left in the numerator. Since we had a com denom, I'd put them together as one fraction. This 1 minus a cosine plus 1 plus a cosine, 1 minus a cosine plus 1 plus a cosine, and the minus cosine and the plus cosine kill each other, leaving us with the 1 plus the 1, which of course is 2, and we are done. 2 over sine of x equals 2 over sine of x. So there you go. Like I said, these problems are comparable to what you would see on the quiz. So hopefully this helped, and good luck with it.